Hello, how is everybody doing? Happy Saturday! Alright, so I'm trying something a little bit new with music today. Let me know if it's too loud, not loud enough, if you just want to listen to the music and not to me. No, just kidding. Alright, I don't need that. Hi Kai! How are things in Germany? All right. Okay, so what do I want to do today? I figured I don't want to look at any actual interview questions. I just want to work on the basics, and I want to implement a merge sort from scratch, a quick sort, and a heap sort. I did practice all of those at some point when I was interviewing, but I haven't implemented them in quite a while. So we'll definitely be going back to the Wikipedia page and figure out how these algorithms work, and then just work through them, see how that goes. Okay. Hi Ur, how's it going? Nice to see you too, I guess. All right, which one should we start with? I feel like I'm most comfortable with merge sort, so I wonder if we should do that first to get started, or if we should do it last, easiest for last. I don't know. Before we do that, let's write a test function. For sorting, it's really easy to have a test function because we can just use the built-in sort function in JavaScript. So const test, I guess, is a function that should take an array. Oh gosh, it's Saturday. All right, is a function that takes an array. Const expected is a that's sort, and const merge sorted is merge sort of A, and then for let I equals 0, I as the merge sorted that let's call it result. Resulted length. All right, is the music good? Is the volume okay between music and my voice? I was playing around with this before in a recording, but this is the first time I'm streaming. So let's see how it goes. Oh. Hello? Auto completion? Where are you? If res of I is not equal to expected of I, console log. Oh yeah, getting warmer. Is it getting warmer yet? Yeah, I guess February is pretty much over. All right, yep, cool. Then I leave the volume like this if it's okay. Okay, so if we have an error, what's a good error message? So one thing I don't like here is A that sort is changing A, so I don't have the original anymore. So let's do const original is A that splice, I believe. A that sort, I don't think it returns anything. I think it's just sorting A. So we do it like that. Console log original, no, original got sorted as result from error, no, error like this. Okay. Hi Wobotag, how's it going? Yes, of course, the best way to debugging is always console log. I mean, we're not really debugging here. This is a test case, and so if it does fail, I definitely want to see where it fails instead of having to go back and start the debugger and see which example failed. So yes, console log is my best friend. Okay, can we easily test this? So const Mergesort is a function that takes an array, and I guess I don't want this to merge sort now. So I want to do that sort return A. Is that matching the signature? It takes an element, sorts it, and it returns it as the result. Okay. This now is also, of course, changing original, but oh well. Well, that copy is a that splice copy that sort, return the copy. So you want to sort or the original a dot sort. Oh, we can use a here, and then yeah, I just want to use this original for the printout here. Yeah, usually just console logging, running something through with a smaller test case, cutting it down, going through the edge cases, that usually finds it. Yeah, I often do something like console log, do we get here, just to make sure I even run into this function or into this branch. And most of the time I don't get there because I have other problems. Yep, test 1, test 2, and then you go on to test 11, test 2G2, test. Yeah, console log just works a lot of times. All right, so let's test a sorted array, wood, and then let's test a more random array. Oh, and of course this will still work, but if I do something like this, it will be broken, because sorting always sorts by strings and not by numbers, so we have to explicitly tell it what to sort for. So, yep, that looks new enough. No sorting. Okay, that seems to work, except it's sorting the wrong thing. If we do console.log result, we'll be very disappointed. Oh, we'll be worse than disappointed. Okay, what's happening here? All right, I'm not going to console log. I'll debug it. Where's my debugger? Start debugging. I don't know if I can debug without output terminal. Debug, open configurations. Oh, I have a Go configuration. That's not helpful. Sorry, Go. Sorry, Vortec. My bot is well, I also don't want to look. So Bogosort posted a link about def rand. I don't think I want a rand in here. This is Saturday, let's be happy. Nobody's forcing anybody to use a language they dislike, so don't hate on any languages. So, well, thanks Natebot. Sorry, no links allowed. If it's technical links like documentation or something, I can repost them. All right. Yeah, there's my debugger. Awesome. Doesn't seem to be quite what I wanted to do, I guess. I'm gonna take the font one step down. Can you still see this, or is this not great. What node am I doing? Am I just doing attach? Am I doing launch program? I forgot. Let's try the first one. Node, why don't you like this? What is it launching? It's launching substring. That's not what I want. I want sorting. Okay, perfect. Oh, okay, it's not a rand. All right, sorry. You know, Reddit has some subreddits that are very nice, but it also has a few that are just a trash file, and you're like, oh my god. All right. So what does original look like? Oh, apparently original didn't do what I wanted it to do. Is that what I want to do? Oh yeah, now original looks much better. So it's slice, not splice. Okay. All right, it seems to work now. Let's get rid of this. No, I do need this. Sorting. All right, so the first one sorted perfectly. Woot woot. Second one, not so great because it's sorted like strings and not like numbers. So let's fix this. We want to sort A and B to A minus B. And I guess the same in our fake implementation here. All right. Let's commit this. Git co-am add a test function for sorting. Wait, I can't commit anymore? Oh. Commit. All right. Okay, so now that we have this, I guess we could add a few more tests. Anything special you want to add? Well, I guess we need this. Doesn't hurt to have some negative numbers. And 42, of course, needs to be in there. All right. And the sort function doesn't need to print this out, otherwise we have a bunch of weird stuff. Sometimes the drama is a little fun though, to read it and be like, oh my gosh, people have so many problems. I feel superior because I'm not on that rant level. And then I go off and rant somewhere else about something even more minor. All right, so let's do an actual merge sort. So how does merge sort work? Merge sorts works by cutting everything in half over and over and over again until you're down to 2 elements. Sort these 2 elements and then merge these small already sorted snippets together. Let's see if we can find a picture. Merge sort. So it's a divide and conquer algorithm. It divides input array in 2 halves, calls itself for the 2 halves, and then merges the 2 sorted halves. The merge function is used for merging 2 halves, and it assumes that the left half and the right half are sorted, and it sorts the 2 sorted subarrays into 1. I hate these overlays. Okay, there's like no space left on the page. No, I don't want Slack and I'll accept the cookies. Oh, Facebook scandals. Deleted my Facebook account quite a long time ago. All right, and then the complexity of Mergesort is n log n, because we're always cutting everything in half, but it needs an additional array. Like typically Mergesort is not done in place, I'm pretty sure. Yeah, like here's the temporary array L and R. All right. Okay, everybody on the same page? Should we Mergesort? Okay, so what's Mergesort doing? How should we make the merge function? So merge function, take one. Oh well, so we need a recursive function because we have to call Mergesort on a smaller subarrays. So if added length is less than or equal to 1, then A is already sorted, so now we can always assume that it is already sorted. So that it has at least length 2. So const merge is a function that takes the array. It takes a start index, I guess. Hey Vindicator, how's it going? What's a JavaScript sort nightmare? Let's try to not make this a nightmare. All right, so we need a left index, a right index. Ooh, L looks like length instead of left, right, and maybe a total length. All right, so we want to call merge. We probably want to return that because Mergesort should return an array. So we want to merge A from 0, length is added length, and the right index is, let's do it like this. Const n equals added length. I don't like to type length over and over again. So the right index here is n divided by 2, but that could, if it's an odd number, that wouldn't be an integer. So let's always make the left half the smaller one. Sorry to hear that you had a headache. Yeah, ibuprofen is good for that. Sometimes it's not, it just gets worse if you already have the pain because you tense up even more. So then I just take some ibuprofen and it gets better and I can sleep or do something else. Okay, so actually this one should probably be up here, right? Let's just call length L. All right, so if we test something that just has one element, it should actually be correct. But then the next one is not correct. Ooh, what broke here? Resulted length cannot read length of undefined. Oh, okay. That would probably be the second round, right? 7 and 27. No, why is it breaking at 27? Let's see. sorting to 28. So in tester 2 it's already failing. Not a fan of that. So we do tester 2, then I mine 7. Why are we not getting a result here? Debug. Oh, result is undefined because what is Mergesort doing? It returns merge of this and merge if it is less than, or why do we have less than 1? If it's less than 2. Yeah, so now it's failing in 29, which means for this one it's correct. Okay. Yeah, we got one test case down. Okay, so what do we do if it's longer than 2? Okay, we want to merge left and right, so we need to, if left dot length. Oh no, we're not sorting them if they have length too. That's part of it. So if the length is less than 2, let's call this MS because we're not just merging, we're merging and sorting. So in reality, we want to return the merger of always using A, I guess, but now instead of left, we want to merge sort left, merge sort right. Okay, I feel like I'm doing something wrong here. Let sorted left is equal to MS, and we're starting at the left index. But we don't want to, so we were going from left to right and from right to L. Should L be an index or the length? I guess I keep it as an index. So we're starting at the same index, but now the length should be right minus left. And this one should be left plus math.floor right minus left divided by 2. Does that make sense, sort of? So we always work on the same array. We use the same starting index for sorting the left one, but we're not going all the way to length. We just go from right minus left. That should be the length. And then the right half that we want to sort starts at half of this length plus left. Let sorted right is A, and now the right half doesn't start at left, it starts at right, of course. And the length is the old length minus what we already worked with for the left half. So right length here, and the middle point is going to be right plus is math.floor half of how long it is. Okay. So we have a sorted left and a sorted right. And now we want to merge sorted left and sorted right. So we want to merge those together into one long thing. Oh, ask your date if they use Arch Linux. Would that be like a plus or a negative point for the date? Well, Mergesort works all the same, no matter how much time you spend on setting up your operating system. Okay, so now that we have a sorted left and a sorted right, now we want to merge those two together. But I feel like this merge function needs to have a left and a, it needs to know some indices, right? So otherwise it wouldn't know which part of A are sorted. Am I getting myself into problems by making this in place? Should this be not in place? Alright, so I'm trying to implement Mergesort here. Calling Mergesort on the array with these indices. Maybe using the indices is the wrong thing and I should just split it up into arrays. Or maybe just a merge one needs a new array. So I'm sorting, I want to merge left and right. And I know my indices. Yeah, this is weird because now sorted left is the whole array except that a part of it is already sorted. I don't like this. I think before I do this, I will just try splitting everything into two arrays and working from there. What do you think? So I want to merge sort. I'm getting recursively calling this left and right. Then I want to merge those two together. And for merging them, I need to know where's the left point, where's the right point, and how long was the whole thing. Alright, maybe this works. So constant merge is a function that takes a sorted left, a sorted right, okay, this doesn't quite work. Sorted left, sorted right, a left index, index for the right, and the total length. And what is it supposed to do? So for let I is equal to left, I is less than right, I plus plus. Oh. Let result equal an array. But then, will this one get really small? How was I thinking about this? No, I think I want... Yeah, sorted at left is the whole thing. Okay, so for let I is equal to 0, I is left in the left index, I plus plus, result that push sorted left of I. So I'm copying over everything that hasn't been sorted yet. Oh, that will totally backfire because I'm calling this recursively and then sorting the left half will be overwritten by what I sorted on the right half. So this is not going to work like this. Oh yeah, yes, Kai, I could use left, right, left 2, right 2, but then it wouldn't be clear what's an array and what's an index. But it's not clear right now anyways, so. All right. So how do I do this? I want a sorted left and I want a sorted right. And then I just want to sort left and right without any of these indices here. So let's assume, yeah, when I'm sorting them back together, I get bigger again. So that should work. So I have a result here. Now, how do I do this? Let I is equal to 0, let j is equal to 0, while I is less than sorted left length, or j is less than sorted right length. If sorted left of I is less than sorted right of j, then I'm increasing I after pushing push. So as long as there's something, so I is less than the length or j is less than the length, if sorted left of I is less than where the pointer and right is, then I'm pushing the left one, and else resulted push sorted right of j, and then increasing the j pointer. Now I just have to make sure if they don't have the same, yeah, that I'm not running over the side. So if I is less than sorted left length, does that make sense? So I have some i's left. Oh, okay. If j is equal to length, or I is less than j. So if j is at the end, no, I don't think this is gonna work. So what I want to say is this is less, or this is less. So if j is at the end, that means this condition was true. So we can definitely push this one. If j is not at the end, oh, then it could have been that I is already at the end, and then I cannot push that. Hey Tom, how's it going? Yeah, I'm trying to re-implement Mergesort right now. So taking it easy today, not doing any actual interview questions, just doing the basics, implementing Mergesort, and then Quicksort, and then Heapsort. Though this is going so slowly, I might not get through all 3 of them. But there's always another Saturday. I'm also trying out this whole sound thing, so let me know if you prefer without any background noise, or if it's too loud or not loud enough. Okay. So, I is less than sorted. I'll just go slow here. If they're both less than, so this is definitely correct. Okay, so now one of them has reached the end. So if I is equal to sorted that left, J has the right length. I'm pushing those. If I is not at the end yet, do we even need an else? Yeah, romantic Mergesort, all right. Okay, let's see if this works. So while both pointers have not fallen over the edge yet, I'm comparing those values and then either push the left or the right value into the result and move the corresponding pointer further on. If we've already pushed in everything that was in the left sorted array, then I'm going through the rest of the right one. You know what? I don't think I need this if statement here, right? I don't think I need this. Honestly, this should just work. So I'm pushing those, and then if I have anything left in the right one, I'm pushing that. If I have anything left in the left one, I'm pushing that, and I don't need an if else. Okay, so this one here is merge to sorted arrays. Let's try that. Hi Brandon, hello, happy Saturday, how are you? What are you up to? We're re-implementing Mergesort here, just for funsies. It's going really slow though, I thought it would be easier, but I just finished merging two sorted arrays and haven't done the rest yet. No, actually this is pretty much all we need, right? Alright, cons test the merge function. It takes left and right. Does it take left and right? Yes, I think it does. Let A equal left and right. A dot sort. Let result equals merge left and right. Oh, and left and right, of course, have to be sorted. For let I equals 0, I less than a dot length, I plus plus if a of I is not equal to result of I. Console log. Yikes. Left, right, got merged into press. Throw. Let's make sure we're quitting here. Test and merge function. I want to take 1, 3, 5 and 2, 4, 6. So I'm putting in two sorted arrays, concatenating them into one new array and using the built-in sort, and then I'm calling my merge function. Yes, it's called merge, and then I'm comparing that. All right. And I don't want to run these tests because they don't quite work yet. This one works, so we can run that one. Alright, it didn't throw, but I guess I want this test function to print something just to make sure it worked. Console log result. Ooh, beautifully sorted array. Okay, awesome. So it looks like we can sort a bunch of arrays. So what if one is longer? What if the other one is longer? What if one is empty? No! 1, 3, 5, 2, 4, 6, 8, 10. Oh, I know. Anybody else know why it is throwing an error on this, why it thinks this isn't the right thing? Yes, status, sorted, awesome. Okay, of course my sort function here sorts like strings. So AB goes to the difference of A and B. Okay, sweet. Looks like it can sort everything. I should have another example where maybe doing 3, 4, 8. Yeah, double numbers is good. Are they both sorted? They're both sorted, so this should work as well. Okay. Cool. So we can sort 2 numbers. And how did I want to do this here? Oh yeah, I cannot use all these indices because I'm sorting the full to arrays, so I need to generate new arrays here and not work with a bunch of indices. Yeah. Cool glasses emoji, because we can merge. Merging is important, especially when you're driving. Yeah, people who can't merge when they're driving, boo. Okay, but we can merge arrays of numbers. So let's finish this merge sort here. So the sorted left one, how do we want to do this? We want the sorted left one. We have left and right and want to merge them together. And we don't want to throw in this whole array. I think that's the problem. So we want to do a that slice. How does slice work? It takes a start and an end number. Okay, start index and end index. So the start index is left, duh, and the right index is maybe just right. So we want to sort from left to right, and the other one we want a that slice from right to left plus length. Is that about right? I think that's about right. So why am I passing in right and length here? Maybe I don't need that. Maybe I always want to just take half of it. So if we do ms of an array, yeah, okay. I think ms of an array should do, if length is less than 2, then we already sorted. Otherwise, we're sorting the left half, which will always be from 0. Let middle equals a that length divided by 2. I need to turn this into an integer math.floor. So we're slicing from 0 to the middle. And then the right one, we're slicing from the middle to the end. Slide. Oops. Slice. Is this how slice works? It doesn't tell me. Okay. And then we are merging the left and the right that are now sorted. Okay. And in reality, can just do this in here, right? We're taking a middle index, sorting the left and the right, and then we're merging those two. Excuse me. All right, let's think about this. We have an array, we take a at length half of it. Now we're going from 0 to the middle, and then what a equals 1, 2, 3, 4, 5. What if I do a that slice 1? Yep, that is all the way to the end. Perfect. And if I do a that slice from 0 to 1, it's just the first one. Okay, so this gives me the 2 halves. And then I'm merging these 2 halves. Well, I don't know. I think that looks pretty good. Should we try it? Okay, doesn't look so good. Oh yeah, clearly. What is missing here? The stop criterion in this recursive function is missing. So if a at length is less than 2, it's already a nicely sorted array. Okay. Oh, go away. So let's run another test. Let's sort a sorted array. Okay. I don't trust this. I want to see what the sorted result is. Sorry about that. It's still winter and cold. All right, ready for some bigger tests? I'm nervous. I'm not sure if I want to run this. Oh my god, it worked. Okay. So, yep, we have a perfect merge sort, and it's actually looking a lot simpler than I thought it would look. So let's move those down here. So we have our recursive merge sort function here. It's stopping once the array is small enough. If it only has one element, it's obviously sorted, or if it's empty, it's also sorted. Then if it's longer than one element, we take the middle index, we're taking length divided by 2. Then we're we're making a new array going from 0 to the middle and another array from the middle to the end. We're calling Mergesort on this, so our sort function here, which eventually will stop here. And so eventually they'll stop. They both have at most one ladder, and then we're merging these two sorted one ladders into two ladders and so on. So we'll grow and grow and grow. Okay, cool. Yeah, and the merge function, this is the test. Here's the actual merge function. We have two indices, one's for the left, one is for the right half, and we're creating a new array. And we're always comparing both of them and then pushing the one that's smaller, increasing the corresponding index, and then we're just comping the remaining ones that are left and we're returning result. Sweet. So we have a test function here, which right now is only testing merge sort. Should this test function also test quicksort? How do we want to do this? Good, yeah. Let's just rename this one test merge sort. And that test merge sort doesn't need to print this. Okay, cool. So 15 minutes to implement the merge sort. Hopefully nobody's asking you in an actual interview to just implement merge sort, because it's mostly like you can memorize it and it wouldn't show that you know how to program or anything, so it's not really a good question to ask. But I think if you're going up for technical interviews where they have this like whiteboard style algorithms and data structure interviews, you should definitely take the time to work through Mergesort yourself. What about Bogosort? Well, I'm kind of discriminating against Bogosort, and I thought we're just doing merge quick and Heapsort, because Bogosort is so slow. It is a lot of fun though, right? Should we do Bogosort? So these three sorts all have on average n log n, and even though Quicksort in the worst case has quadratic runtime like Bogosort, in all real-world use cases it's pretty fast, and it's some variation of Quicksort is usually what the library sorts are doing. I don't know. So Bogosort is where you always compare two to each other, right? And then move them up. Maybe we should not do Bogosort because we'll just remember how not to do something. Okay, should we move on to Quicksort or Heapsort? So Quicksort is the one with the pivot and Heapsort is the one with the heap. Surprise! Oh, I forgot to say, thanks for the follow, Mr. Blade Brown, and also D6Nilxias, thanks for the follow, and Bobotag, thanks for the follow as well. Usually I get sound notifications, but I believe because I have Chrome for sound, should we change this? Oh, you can change this. So I only have Chrome as a source. Select application, OBS. Let's see if I will also hear these sounds then. Okay, because usually, do you hear a sound when somebody subscribes? I think you do, right? Bogosort, shuffle the array until it's in order. Actually, I like this. Let's do that. Should we do that? I think I want to do Bogosort just for the fun of it. Yeah, and you should. So actually, when I was on the Chrome team, at some point I deleted an actual, I want to say, oh yeah, there was an actual binary search manually implemented in there, and at some point I was able to delete it and just be like, just use STL vector that search. Like, that is silly. All right, let's do Bogosort just for the fun of it. Bogosort. Bogosort is a function that takes an array. Oh, typing fingers, what are you doing? Okay. And Bogosort. All right, here's the test function. Where did my Bogosort go? Even Bogosort. Yeah, it's always relative. If you compare Bogosort to Bogosort, that's perfect. Okay, shuffle the array until it is in order. How do I shuffle the array randomly? And also, how do I know that it? Oh yeah. So const is in order. Takes a. Let previous equals number dot negative infinity. For let I is equal to 0, I less than a, that length I plus plus if a of I is less than previous return false, and then update previous to the current index. And at the end, if you never return false, then you can return true. Is that correct? Is in order, is sorted, so we're going through it. If it is smaller than the previous one, it's false, otherwise keep going. Length. Of course I had this wrong. Thank you, Kai, you're so good at spotting those. All right, so random shuffle. Let rand equals shuffle of A, const shuffle return. I'm cheating. And we'll fix that in a second. While not is in order, is sorted of A equals shuffle of A. Shuffle of A. Okay, does that look right? Modulo the fact that the shuffle function isn't correct. So we have an is sorted function where we're checking if A is sorted. You know, I don't know why it's not showing me that. Oh, maybe I have spell checking turned off. What? I mean, Floxy is not a word, right? I don't know why it doesn't show that. I'll figure that out at some point. So we shuffled the array, and while it is not sorted, we do this. Okay. Let's run this and then fix the shuffling. Uh-oh. I think my is sorted is wrong because the first shuffle should already have... Oh no, I know what's wrong. I cannot... A that sort doesn't return anything. Okay. No? No! Why don't you work? Okay. So if it is not sorted, then A is equal A that shuffle. And let's set a breakpoint here and debug this kid. Okay, so we have an array with one entry. Previous is negative infinity. Length is typed correctly. A of 0 is less than previous. Yeah. Then previous is A of I. Okay, and now it's returning true. So it's returning A. Why is this broken? Let's come to the next one. Okay, empty array. Should also return true. Okay. Let's go to the next one. 1, 2, 3, 4. Okay, can't see anything. Previous is 1. I should be 1 bigger now. Alright, that seems to work, right? That's always true. Which one is it stuck at? So this one's not sorted. Oh, wait a second. Why is it not running on a sorted one? Oh, because then we shuffle. Okay, so this one should return false at some point. Yep. And then we shuffle. Oh, and then we return A. That's fine though. Why was I stuck in an infinite loop? Oh, I'm not stuck in an infinite loop. Never mind. Okay, so this one works, except we have to fix the shuffling because our shuffling is just sorting. So how do we shuffle? What's a random way to shuffle? What is a random way to shuffle? So we have n indices and we need to switch these indices around. Hey Bilbo1, so we're not doing interview questions today. We're just going back to the basics and re-implementing Mergesort, Quicksort, and Heapsort. And we get distracted by implementing Bogosort, which means shuffle the array until it is sorted. So we're just doing that, and I'm just thinking about how would I generate this shuffling. That's a good way to shuffle an array randomly. So I'm thinking for every, I could go through the array and always randomly generate an index and then pick this one as the next index. I guess that would work, right? Run shuffle array. How can I shuffle an array? Okay, how to randomize? I want to shuffle this to something random, I guess. Oh, this has been answered before. Wow. Yeah, so it's generating a random index and putting it there. Ooh, ES6 version. Oh, this is flipping two arrays. Well, I guess, should we do this? So we're not sorting, we're shuffling. I really hope this is random or we will never get our result. So we're going through from the end to the beginning, and we're setting the new index as a random number multiplied by one more. And then we take the floor. So math random goes from 0 to 1. So this one will go from, say we have 4 elements, so it will go from 0 to 5, but it will always be less than 5. You can never reach the 5, so math floor will be between 0 and 4. And then we are switching AI with AJ. So we're assigning I the j's index and j's the ith index. So we started with the last element and it's now somewhere further in front. But then we will iterate over it and we might be switching it back. Is that really random? And like, why would we have to start at the end instead of start at the beginning? Because if we start at the beginning, oh no, so we start at the end and we put something at the end and it can never move to the front again because we're decreasing this I here. That's why we start at the end. All right, let's see if this sorts any. Oh, that will. Bogosort is so fast, isn't it? I don't trust this. Is it really sorted? So test Bogosort. I don't know, looks sorted enough. Should we make this harder? Okay, I'm kind of excited that Bogosort is working. Thanks for suggesting that, Kai. Okay, this might have been a bad idea. Let's see if Bogosort can handle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 elements. So fast. So good. Does it make a difference if I have more random numbers? Oh really? It'll get slow. You don't say. I was assuming it would get much slower early on. I'm pretty surprised this is still working. It is probably I'm not really testing the right thing because I have so many duplicate entries in here, which will all be considered correct. Where's my test Bogosort? Here, I don't want all this. Oops. Yeah, I don't want this printed out. Well, so turns out Bogosort is surprisingly fast. Or maybe I spoke too soon. Let's see. Nope. Well, maybe from now on I'd always use Bogosort for everything. But I guess this is only 30 entries. But I assumed it would, I mean, to get 30 entries sorted, what's the complexity to get 30 entries sorted randomly? Because there is, how many options? There's 30 factorial options. I mean, there's like a ton of options. How is this correct? Yeah, if I'm lucky, it's constant time. But, okay, I'm a little bit... Do I maybe still have a sort somewhere hidden in my Bogosort, so I'm not doing the random shuffle? I'm not fully trusting it. Oh, you know what? This is not... How is this... How is the test not failing? Because I'm only shuffling once. What the... How is this not failing? Because I doubt that if you have 30 numbers and you randomly wait until they're shuffled correctly, okay, so big failure, big test failure. How is Bogosort not screaming here? So I'm sorting. I do Bogosort A, which gives me a result, and then I'm sorting. So I guess somehow I forget. So Bogosort gives me a result. Is Bogosort returning the same A? Yeah, JavaScript. Oh, JavaScript, you little rambunctious thing. All right, so do you see what I'm doing here? I am Bogosorting result, which is just returning A. And then I'm also doing A.sort, so result and A are the same thing here. I guess I could shuffle A dot slice? No, because I'm just assigning it to A. So I'll leave shuffle A, but then test Bogosort. Should no Bogosorted slice. So here I'm copying it, and now it should be wrong, right? Would A.slice do the same as the spread operator of A? Yes, I think it does. Actually, I might start using that so I don't have to wonder if it's slice or splice. So this one gets sorted as this random string here. Let's just make sure it's really random. This is not random, people. This is twice the same one. Oh no, it is random. It ends differently. Okay. Whew. Okay, let's do what you're suggesting here. This is a little cleaner than just having random slices with no entries in it. Yep, I think this is still working, so let's stay consistent. And now let's fix Bogosort. So while it is not sorted, because one shuffle is probably not enough. Okay, so this is working now. Now, how big can we go? Yeah, and now it already takes time to shuffle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 entries randomly. Because 11 factorial, there's already 40 million choices for that. Let's see how long this takes. Yeah. Oh, that was quicker. Oh, yeah, because it's random. Okay, we got lucky. Oh my god, I'm loving this. I love how unpredictable the timing now gets. This is amazing. It also gets slower every... Nope, there was a good one again. All right. Oh, I'm so glad. I never had Bogosort implemented before, so this was fun. Thanks for suggesting it. All right, so back to more serious stuff. I think I want to implement a Heapsort because I don't think I ever needed to implement my own heap. So I want to implement a heap, I think. Okay. Let's take out this last Bogosort, otherwise every run will take several seconds. I don't want to do that. And so Heapsort, we will change this. Test Mergesort. Test sort function. Takes a function. Test Mergesort. So those should all be no, wait a second. Wait a second, what did I just change? Wrong. Test merge function is not what I want to change. I want to test sort function. This is test sort, and it should take a function, and then it's applying f to this function. So test sort. And it's always using Mergesort. No, f is not a function. I'm calling this in 123. How is Mergesort not a function? Mergesort is totally a function. Okay. Okay, so I have a test sort function. Did I already copy Heapsort? Yes, I did. I guess we don't really need those anymore because we're already testing that within the test sort when we do merge. So we don't want merge, we want Heapsort. Okay. I don't understand why this doesn't work if I do multiple lines. Heapsort. Okay, don't judge me for not knowing how to edit stuff. Okay, so we get Heapsort, and now we just have to implement Heapsort. So how does Heapsort work? I believe we are creating a minimum heap from the inputs, and then take out every element in the heap, push it into a result. So let result, let heap equal a new heap of A, and then while heap dot size not equals 0, heap dot pop, result dot push whatever we pop from the heap, and then we're returning the heap. Except we need to implement this heap, but I think that's kind of what we want. So if the thing is small enough, we just return it, obviously returning the result. That's why it's called result, because that's what we want. We create a heap from the initial input, and then while something is in the heap, we pop from it, push it into the result, and it should be a min heap. And if we use the proper heap functions, best case scenario is complexity n log n, because the heap is a binary tree, so it has height log n, and we're doing this for n elements. In the worst case, yeah, I guess, no, in the worst case, it's still n log n, because this should always be balanced. Okay, so how do we do this heap? Let's see if we can find some pictures. So we're using a binary heap. Every level is filled except possibly the last one. Stay as far left as possible. So build a heap from the input data. All right, so class heap has a constructor that takes an A, and I think we'll do it differently. Don't initialize it with anything, but then we need a push function, and we need a pop function, and we need a size function. So we're generating this heap here, it's empty, and now a dot for each. For every element, we want to say heap that push the element. So you're putting them into the heap, and we just have to implement the push and the pop and the size. So size, we can use this elements that length. So that's already done here. Okay, so this compiles, and we just need to work on the push and on the pop. So the idea of a heap is you have the elements in heap structure. Like in a binary tree, and your first element has children number 2 and 3, and then these have children 4, 5, 6, 7, and then these have 8, 9, 10, 11, 12, 13, 14, 15, and you can see a pattern here how child of I is 2 times I and 2 times I plus 1, right? Like the child of 3 is 2 times 3, 6, and 7. Hi Kuro, how's it going? So we're just doing some basics here for algorithms that you need in interviews, and we're just re-implementing Heapsort right now. We just implemented Mergesort, then we had some fun with Bogosort, because fun's always good. Bogosort is awesome. And sometimes it's really slow if you do the right shuffle right away. And now we're doing Heapsort. So we're just looking how you would implement a min heap. Okay. So when I pop an element, if this that elements, if this that size is equal to 0, console log cannot pop on empty heap. You know what, I don't need to log this if I'm throwing anyways. Okay, and let minimum equal this dot elements of 0. And now we just need to reshuffle the elements in here. So we would say, we'll take the last one, put that at the top, and then shuffle it down. So let last equals popping the last one, setting this to the last one, and now we have to call a shuffle function or something like that. So we want to move this element down until it's at the right spot. So if how do we do this? So we want to get this back in order. We know we need to look at the first element right now. So this that shuffle of the first element. Shuffle of I is a function. No, it's not a function. It is a function, but I'm writing it differently. So shuffle of I, const left child is equal. So we just said it's I multiplied by 2, but here the index is 1 bigger than in a real array, because in a real array we would have 0, 1, 2, and so on. So I believe we have to do this to get the first child. Const right child is equal to 2i minus 2. So we could say I times 2 minus 1. Is that correct? Is that the same as I minus 1 multiplied by 2 plus 1? It's 2i minus 2 plus 1. Yep, that's just this, but 1 bigger. So you have a left and a right child. Let n equal this. Oh no, n is just a size. So if left child is less than this set size, and a of I is, right, if a of I is bigger than the left child, then the left child should go up. Okay, so how do I know if the left or the right child should go up? I'm confused because a binary heap is not a binary search tree. Yeah, so here's the left and right children. How do I swap this up? Okay, so what's the sift down function here? Heapify sift down, okay. Okay, if it's less than the child, then swap it. If there's a right child and that child is greater, I need a picture for this. Min heap, maybe? Okay. No, I can't read 15 pages now, sorry. A min heap is a binary tree such that the data contained in each node is less than or equal to the data in the node's children. Please have pictures. Okay. Minimum heap, the top's always less than the other ones, and I guess the left's always less than the right. But both bigger than this one. Okay. Yep, so there's the children. Okay, 6 is greater than its first child, so swap them. To do this, it takes the element, moves it to the spot, and compares it to its children at position 2 and 3. Okay, but why would I put it in the left or in the right? I'm not sure I understand this. So take out 2, move 6 to the front. 6 is greater than its first child. I mean, if I'm always comparing with the left, so swap them. 6 has 2 children, so we swap again. Do I only compare to the first child? Because if it's not greater than the first child, it's definitely not greater than the second child, right? Okay, so binary pop. We're getting the first one, we take out the last one. And then we call this sync down function. The sync down function bubble up. Here's sync down. Okay. So I take the length. We have child 2 and child 1. Okay. If child 1 is less than the length, so child 1 is on the left of child 2. And if child1 is less than the element, then swap it. What was swap? Swap was null, okay. If child2 exists and child2 is less than this or child1. Ah, okay. Okay, so always swap it with the one that's smaller of the two. Got it. Okay, otherwise swap them. Okay, we can do that, I think. So we have a left child and we have a right child. If the left child exists and if the left child is less than a of I, left swap equal null. So now we want to swap. Should I remember the index? Probably. Swap is equal to left child. Now if the right child exists and if the right child is less than, if we have swap, then we want to say is it less than a of left child, otherwise a of I. In which case swap will equal the right child index. Now if we don't have swap, it's already, we're not swapping anything, so we can, the heap is ordered and we can leave it as is. But if we do have to swap it, so if we do have to swap it, then we're calling shuffle again at the end, but what are we swapping it with now? So then we say a of I is equal to a of swap, and a of the swap index, swap, is a of I. All right, obviously that does not work like this. Let's use ex6 magic. What could possibly go wrong, right? Okay. So we have to swap. So swap has the smaller one of the two children. So we're swapping those two around, and then we are shuffling down at this point. And shuffle is a bad name, so these documents, this documentation calls it sync down. We're calling sync down again. They're doing sync down in a while loop. Is what I'm doing correct with the recursive function? So while true, they're breaking out once they're not swapping anymore. And they're switching the content. They said n is equal to swap. What was n in the first place? Yeah, n was the thing they're calling it with. So my recursive function should work, I think. So we're taking out the minimum, and we're popping the last one, setting it to the front, and then we're sinking down from the first element and returning the minimum. Okay, I feel like I need to test just that. So here I'm doing heap.pop, and I think before, after every heap.pop, while heap size is not 0, console.log. Oh, there's our friend console.log again. I want to do this. So test sort. Ooh, nothing broke except I'm calling test sort with heap. Here's the Heapsort. Oh, we don't have a push function yet, so never mind. Except, why is the test again not failing on us? Oh, gee, these tests. So we're returning the sorted array in Heapsort. No, still not failing. I know what I'm doing. I'm going through the result.length, which in my case is 0. So if result.length not equals a.length, okay. Yeah, I never checked for the fact that I might just get empty arrays back. I could fix it by just doing this. I think I like that a little better. Nah, it's not quite true, because if I always return something, then I'd also be wrong. Okay, got sorted as nothing. So let's implement the push function. For now, let's do this, that elements that push. Oh, and push, of course, gets an element. We need to push here. How can we push them in so that they're always sorted? We need a different test case here. So let's turn off these two and pick one from here. Oh yeah, if the array is sorted, that works. Okay. All right. Nope, still doesn't work. A is not defined in 127. What was I thinking that A is? A is this does elements. I just want a shorter name, so I'm explicitly not copying this that elements. I just want a shorter name here because I'm using it quite a bit. Sync down is not defined. Sync down is not defined. Maximum context size exceeded. Okay, in 156. So I'm calling sync down of 0. Sync down of swap. Swap is null. If we don't have swap, we return. Otherwise, we flip them. shouldn't the left child be going down? So what numbers is swap getting? Oh, minus infinity. Wait, how did that happen? Alright. I don't want to debug these two cases. Okay, so we're implementing Heapsort, and I'm just on the sync down method, and somehow I got an infinite loop where the swap index ended up being minus infinity. So I'm debugging this now. So I'm syncing down position 0, 0. Oh, yeah, this cannot work because, oh, gee, yeah. Okay, so I have position 0. And if I have position 0, I want the left child to be 1 and the right child to be 2, but this one here would be a negative number. So I do 0 plus 1 multiplied by 2 and subtract 1 again. I think this is wrong. So really what I want is 0 has children 1 and 2, and then those have children 3, 4, 5, 6, and those have children 7, 8, 9, 10, 11, and 12. Is that right? 0 has children 1, 2, 1 has 3, 4. So multiply by 2 plus 1. I multiplied by 2 plus 1. Is that always correct? 1 multiplied by 3 multiplied by 2 is 6 plus 1 is 7. 5 multiplied by 2. Oh, that seems good enough, right? Plus 2. Okay, let's try again. Seems very infinite still. Okay. So, Heapsort. Oh no, did I lose my breakpoint? I think I lost a breakpoint. Okay, I is 0. Left and right child is 1 and 2. Hey Digital Gnome, how's it going? We are working on Heapsort, so not a real interview problem, just going back to the basics and re-implementing Heapsort. We already did Mergesort, and we're stuck on Heapsort right now. Somehow I got an infinite loop in here. So I have a left and a right child, and now I'm checking if left and right child is less than this that size, which should be true because this that size should be 4. No, it should be 3. 0, 1, 2, yeah, 3. Okay, so I'm setting swap to 1. Now I'm checking if 2 is less than 3, yes, and I'm checking if 3 is less, if 2 is less than 3, which should be not true. Okay, I do have a swap, so I'm swapping this. So now 4 is 2, 4, 3. Okay. Swap was index 1, and now I'm starting over with 1. Okay. So left and right child are 3 and 4, which means this should not happen. This should not happen. I don't have swap, so I'm returning. Okay, makes sense. kind of what I wanted. Okay, and then I'm returning the minimum. Why am I pushing here? Oh yeah, so I'm doing this again. And what are the elements? Yep, my array only has length 2 now. So I have a left and a right child, index 1. The right child is already out of bounds. Left child is less than the size. 3 is not less than 4 though. Oh, I see what happened here. If left child is less than, I need the value of the left child and the value of the right child. Okay, that might have been it. Crap. Still stuck in an infinite loop. Okay, so now I'm array with 2 elements in it. So left child, this should not happen, this should not happen. So I'm returning. Okay, and I'm popping the last one. That pop has 1, 2. Where the heap elements? Yep, has 2 elements in it. A just has 1 element in it now, and I think that's where I'm ending up getting stuck. This should not happen, this should not happen. I'm returning 4. Heap size should be 0 now. Oh no, why is there still a 4? I think I know what I'm doing. I know what I'm doing wrong, I mean. Yeah, because I keep getting stuck here with 1. So when I'm calling sync down here, I always set the last element to this, even though maybe I popped to the end. So minimum is the last element. And now if that size let's be explicit. If we have more than 1 element, no, wrong button. Sorry, if we have more than 1 element, then we're doing all this. And otherwise we're done right away, because if we just have 1 element, where's the pop though? Oh yeah, here's the pop. So we always need to pop. But only if any elements are left are we setting the first one to last, because if we don't have a first one, we don't do this and we don't sync down. Okay. Yep, and it comes out sorted because we put in something that was sorted. So let's put in something bigger. 5, 8, 9, 12, 13, 15, 16. Ah, crap, hit the wrong button. Sorry. Yeah, so it's kind of my goal for this year, I guess, to use the debugger more, because Somehow console log seems more reliable, but it's just so much more work, and you're adding all the console logs in and then you're taking them all out again. So my goal this year is to just use the debugger a little more. Oh, and I'm printing the heap all the time. Yep, because it's getting smaller. So I think that like reshuffling kind of works. It's hard to tell because it already was sorted. Oh yeah, but the heap will always be sorted. Never mind. Okay. So what is wrong right now is how we're pushing elements. Because what we have to do when we push is we have to organize the heap as well. Right now we're only doing that when we're taking the smallest element out. But really we have to do that. But just want to make sure that the test actually does fail. Yeah, it does fail because it doesn't really sort yet. Sad kind of sorting. It did sort these last numbers, but not really too much more. Okay. Oh, and I'm afraid we won't have time for quicksort. Well, then let's do a quicksort next time. But let's finish the push function here. And then we'll be done. So every time we push an element to the end, we have to move it up as high as it can go. So let I is equal to this stat element stat length minus 1, because that's the index of this element E. How do we get the parent? So the parent is I divided by 2. So we're dividing 11 by 2 plus 1. And then math.floor. So if we're dividing 10 plus 1 is 11 by 2. Haha, no, that's wrong. Wait, are these numbers right? I have 11, 7, 8, 4, 3. Is this even right? So there's definitely one missing here. There needs to be 13, 14. So if we do minus 1, so if we do 8 minus 1 is 7, divided by 2 is 3, 7 minus 1 is 6. Yep, if we do 14 minus 1 is 13 divided. Okay, I minus 2. And then that divided. Is that right now? So if it's 14 and we subtract 1, we get 13 divided by 2 is 6. And the same for 13 minus 1 is 12 divided by 2 is also 6. Okay, so I think I get the parent right. Let's make sure 1 and 2 is 0 and 1 divided by 2 always gives us 0. Okay, so we have the parent, and now we have to compare. Similarly, when an element has to be added to the heap, it is put at the end of the array and allowed to bubble up by repeatedly exchanging it with its parent until we find a parent that is less than the new node. Hey MacJack, how are you doing? How's your Twitter extension going? I'm not doing anything remotely as fun as a Twitch extension it is, right? Not Twitter, Twitch extension. I'm just using good old Heapsort here. So no real interview questions today, just the basics. We did Mergesort and now we're doing quicksort. And for fun we did Bogosort, which failed pretty soon. And also it does not have predictable performance, I have to say. Okay, so this element that push, and now we want to do bubble up of I. Let's do bubble up, takes an index. Of course we're calling this step bubble up. So I is, oh, sorry, we're taking bubble up of the last index -1. We're finding its parent, and we will keep calling bubble up. It's kind of strange to me that I find recursion easier than a while loop in this case. This one doesn't return anything, so it's already done. We just need to make sure it's bubbling all the way up. If again, I want to do const a is equal to this dot elements, just to save some typing. So if the parent is bigger than the current element, then swap just waking up. Nice. Good morning. Aren't you on the East Coast as well? Well, I'm jealous that you can sleep so long. I always wake up super early. It's really rare for me to ever sleep really long. Okay. Or maybe you're not on the East Coast. I'm confusing that. Late last night. Early this morning, I would say, right? Okay, we don't need this extra variable here, do we? Actually, maybe I really don't want a recursive function. While parent is bigger than this, we want to say a of parent, a of I is a of I. Oh, modern JavaScript is so nice. No extra variable for the swap here. While the parent is bigger, and then we need to reset these numbers. So now we need to say I is the parent, and the parent is this. So while parent is bigger or equal to 0 and the parent is this, we are bubbling up. Does that make sense? Oh, cool, UI work. Yeah, I never do any front end, but it's so much fun when I do it. It's really slow, but it's like, oh, I can see stuff and I can move it around. Sometimes that's nicer than just working on libraries all the time. Okay, so I'm bubbling this up. I'm taking the parent. I'm doing a shortcut for this element, and then I'm checking as long as parent is a valid index. If parent is still bigger than my element, I swap those two, and I set I to the new parent and parent to the parent of that one, and I keep working my way up. Maybe that was it. Oh my god, I think that was it. So sometimes I debug, but sometimes I console log. Where was I console logging? So we definitely don't want to console log this, and then in the Heapsort we don't want to print the heap. Oh no, this is okay. You can only see my head. Sorry about that. Is it better now? Worse? Hello. At some point I need to get a different setup. We have more than one monitor, so I can actually see my screen. Well, I hope you like my hair. Sorry about that. I'm just like, oh my gosh, a Heapsort. All right, I'm still here. Sorry about that. Yeah, I need to put OBS in the like tiny empty space that my screen still has and like watch myself. Completely forgot. I was doing too many heaps here. Okay, so this seems to work. Let's add a few more test cases. Let's do the empty heap sort. Sweet. And let's do a bigger heap sort. Awesome, that seems to work. And also just in time after 2 hours of streaming. Is Heapsort one word? I think it's one word. All right. So what did we do in Heapsort? If it was a small array, we were already done. Otherwise, I don't think that I need that, right? Yep, we don't need that. So we take a result array and we create an empty heap, and then we push every element one by one into this heap. While the heap size is not empty, we always take out the minimum and push it to result and return the result. And the important stuff is here in the push function. So when we push an element to the heap, we add it to the end and then we bubble it up. And by bubbling up, we always take the parent and we bubble it up as long as the parent is too small, too big. Yep, so if the parent is bigger, then we switch those two and we keep bubbling it up. And the other important function was the sync down function. When we pop the smallest element from the heap, we just take the last one, put it to the top, and then move it down to where we need it. Put the camera on microphone arm, you can give it a better angle. So I actually have a little tripod here, but I wasn't really liking where I had it on the tripod with the light, so I ended up just snapping it on my laptop. You should be watching the code, not me. But yeah, I'll try to remember next time to watch my camera so I'm at least in the picture. And also, hi Jim, how's it going? Where are you joining us from? Okay, yeah, so the sync down one is moving that down, and we're always making sure that as long as we are bigger than one of our children, we swap out with the smaller one of the two children. And I'm calling this recursively. You could easily have a while loop just like in the bubble up function. Okay. All right. I hope you enjoyed the stream. So we didn't get to do Quicksort, which is the one with the pivot element, but we did Bogosort, which was way more fun. But I'll probably do a Quicksort next week. All right. Is there anyone we should rate? I guess. Any other software engineers on streaming right now? Any web programming? Do you have any suggestion whose stream we should be rating? Maybe I can find that on my phone. Let's see. I have to admit, I'm not super successful so far using the phone app. Okay, add filter, software. Wait, isn't software filter anymore? Category. No. Software development. Okay. Something on Unity, bot development. Who should we raid? Oh, Lucilin is doing JavaScript dev. Well, why don't we take Lucilin then? So I guess I can just type into the chat raid, right? Let's see how that goes. All right, thanks everybody for joining this week. I see you next week when we'll finish this up with Heapsort. Yeah, I can just push that. So if you want to see my code, it's on github.com/fhinkel/twitch. And let's see if this rating works. Should have read the docs before doing it. All right, thanks everybody. See you next week. Have a great weekend. Bye-bye. All right, so it does look like it's rating somebody. 2 seconds, 1, have fun, bye-bye.